The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea, and we'll touch on Maunaloa today, volcanoes update. April 21st, 2022 is the date today, and it's been essentially more of the same on Kilauea. Viewing's been great, there's been no change in the threat to people. We'll review the changes essentially. We've had a little lull that just ended. That has put a little bit of a damper on that, really this new era, this new phase of really active perimeter activity that we've seen for a couple of weeks now. Lots of ooze-up flows, lots of flows from the West Vent Complex itself spilling out into that perimeter area. And we'll recap all those changes for you guys here using the time-lapse cameras from the USGS HVO, collected by Dane and Bob Martin. Mahalo, you guys. We'll be talking about your questions as well as we go through this, so submit questions in the chat and Dana will be leading discussion there and collecting some for us to discuss, passing some on here. Let them know if you have any issues with our audio or with our video, as always. And with our intro out of the way, let's get into it here, right? What you guys are looking at is the last 5 days of the V1 camera that's been repositioned and essentially zoomed out a bit. So you can see on the right side here, let's see if I can draw on a screen here. This is that West Vent Complex. This is a series of spatter cones that are emitting lava from time to time and glowing and putting out lots and lots of gas. The persistent lava lake is this feature over here with this detached little pit we've been calling the southeast pit, with that has a little connection, a little spillover point there. And then all the way around here, this is that main active lava lake. And with circulation of the lava coming up below this whole area here, and also underneath this whole zone over here, which was a part of that active west vent pond, we were calling it, that's since gotten all the way crusted over. You can see little parts of it over here sticking up, but it's really become part of this larger crack complex that goes around the entire edge of that old core of the hardened floor of the crater here. So that part is still rising, and lava is leaking out around the edge of it on these crack systems, including the west vent complex, and putting up this big ooze-up. Another one down here at the bottom comes up. You can see it actually recedes here and leaves a little pit, which is pretty. That's our new view we have for the past 5 days, since the cameras have been stable and steady in one spot there. You see the flows coming out from the west vent complex. They've been mostly pouring over to this side, right against the crater edge. This is a wall, a crater down here, and that's been the story here the last week, and really the last 2 weeks. And so the last couple of days have changed it a little bit, just because we've had that lull that just ended. And so what we're going to do today is jump right into the viewing and kind of what's happened over the last week first. And this is a S1 camera that we've often used as a proxy, looped over the last week here. So there's the reverse angle. Before we were looking more this way, and now we're looking back that direction. West vent cones are over here. You see all the lava flows pouring against the wall of the crater in that perimeter zone right there, and an ooze-up flow coming up, and then back over here and over here as well. See the glow of one down beneath the crater, on the edges of it sticking out down here as well. At the end of the sequence here, you do see the lava level drop down a little bit, and maybe if I zoom in, you guys can actually see more of that. But if we look at the actual persistent lava lake zone, you can see a crusted over archway right there, over top of that pathway of lava into the southeast pit. A little overflow of the pit as well during those surges and lava into this area. The lava drops down a little bit, forms that archway, and then as the lava level forms a cascade, as it's dropping further and further, that archway collapses, it seems, shore form there. So the lava level did drop during that low that just ended earlier this morning, I want to say, early this morning or overnight last night. But you can see this entire time, the lava never stops moving in this video at any point in time, so it hasn't ever stopped all the way. Really what we've seen is a pattern of when we see that drop down in the lava level, you start to see the reduction of these ooze-up flows around the perimeter. So that's the S1 view, S1 camera view over the last week. And what we do now is we're going to go into a series of clips that I've pulled out of Two Pineapples, mahalo you guys, Two Pineapples on YouTube. I've been doing live streams of Kilauea volcano, so I've been doing long live streams. It can be 3-4 hours long. It's awesome. You guys are doing great. Definitely a challenge with all the weather and equipment and all of that. But what I thought I'd do was pull out a little bit of it and share with you guys to show a little bit of what's going on. So kind of the view zooming in here, that main persistent lake, I've sped it up here. You can see that main circulation, that pit's in the bottom left here. You can see as it comes dawn and the sun comes up, the colors change, pretty cool. Lava lake is still moving over there, but there are other features to look at around there. For example, right over here, over that area near the crack and close to that west vent pond, you see a couple of these spatter cones, and I've sped it up as well, but you can see pretty regular little pulsing of gas and burping out some lava, building those little cones. As well, you can see the pit itself, you see some bubbling, and occasionally, once again I sped it up here, a spillover. You see this nice breach of the main active channel or active lake wall there, and overflow down over here in that direction. There was that crusted over archway. Lava is going underneath here and feeding this lake, which is now starting to overturn. So you can see when you're there for as long as these guys are, you can really see quite a lot of different changes happening. Still sped up, but you see all the bubbling in the southeast pit. It gets less and less and less. Finally, it crests all the way over. Lava still coming in. That's how that overturning process works. And different angle of that far side of the pit. Sometimes this is the zone you see more active. You can see building a little cone here as well. The lava going down into whatever drainage area is down there and circulating back down, and the gas coming up to form the spatter. So this one, let me rewind this just that last few seconds here. And right, so there's that area, lava going down, gas comes up. But over here to the right, there is one of those big ooze-up flows, that one maybe in that northwest quadrant. And panning further over, across other area of rubble, another big ooze-up flow down over here. Occasional spattering and bubbling through the crust there as well. Zooming out, panning over, you can see the rest of that downdrop block. You can see how much of that hole there still is left to fill. But these guys on a clear morning zoomed all the way in Mauna Kea, and look there you can see some of those observatories at the summit, that road coming down. It looks like that was the very long baseline facility. There they are. Mahalo you guys, 2 pineapples, for sharing that with us here. Looked at just the little highlights. If you really want all the action, you gotta go and see the full length of their stream there. But since we're just doing review, that's our MO here. We'll show you guys some of the USGS imagery and time lapses as well. So this is one of the photos released by the USGS, zooming in at one of those zones of lava going back down and spattering up. Right, so it's not exactly that same spot, but similar on that south on that east side. It's viewed from the west, so you can see the direction of lava would be going that way, and it's going down into, essentially circulating down into there. It's basically agitated by all the gas bubbling up and throwing up the lava out, and the crust can't really form there. It's actually being thrown up against the upper part up here, dangling or attached or whatever gets on somewhat stable land will end up being part of this cone, and whatever doesn't will fall back and get recirculated. So that's a pretty cool picture. It kind of relates to what we just saw there. April 15th, that was taken by USGS HVO and by JM Chan. Okay, so within a national park, those views that we just showed you guys were from Kīlauea crater overlook, which is more or less right in here on that south side of the caldera. Because there are some big ooze-up flows, if there are some on the southeast, kind of over here a little bit more. If there are some on the southeast part, then you can see them from Kilauea overlook as well. And so that area is good for that as well. Anything kind of over here, but you can't see the vent as directly from there. There's a little bit more of a cliff in the way from there. But there are more and more areas all over here on the east side being reported that lava's visible, and the active lava lake, the West Vent Complex, some of the ooze-up flows, because everything is coming up higher and higher and higher. It's just coming further and further into views. And it seems like one of the areas that's benefiting most immediately here is back over here, this area on the east side. Maybe not quite the volcano house. I have to go back there to check again, but I wouldn't be surprised if very soon, if not already, you start to see some of that activity from the hotel itself. Pretty cool times to seeing such great activity. It's going to get better and better if it keeps coming up. And just a reminder on the hazards here, we don't have any of these things of lava going to the ocean, lava going out and going through breakout areas or having explosions, because it's all within that larger pit. All we have here is the diffuse ash and gas cloud and volcanic smog to deal with as our main concern, right? So the national park has been clear essentially every time we've looked, especially around these viewing areas. There's an area down here on Kahuku that sometimes gets more of the fog, but for the most part it blows to the southwest for the majority of the time. Not always. Sometimes you can have something that maybe you can smell, but it hasn't really come into advisory levels that I've seen at any point over or for a long time now. You can go to the park and check all the sites and all that if you'd like to see that for yourself. And of course, check the National Park website for their current advisories and updates, everything else that you need. Okay, so since it's not just a national park, it's all our island communities here. Less so the other islands, but the big island here, you can see, is still getting some diffuse fog. South part of the island, southwest part of the island. Getting a little bit up into Kona, but doesn't seem like it's really that much in here. But if you guys see it from where you live on the island, feel free to drop it in the chat. Let us know. Give us a live real-time report of how the fog's been. And share that with our other listeners too. All right, all that gas, for the most part, in the past, has been coming out of this west vent complex. And so here's a close-up of some of those cones here on April 15th. You see, just a few of these cones here, but for the most part, a lot of gas coming out. You know that there is more happening outside this photograph based on everything I've showed you guys so far in this short update, even if this is your first time joining us. Jam Chang once again with photo credit there. And once again, Jam Chang. Wider view of the caldera here. So here you can see that west vent complex right here and all the gas coming from it. But I really wanted to point out, you see other gas sources kind of all over the place across the caldera floor now. It's not so much like it used to be before, right? And I'll show this a little later when I show some of the before and after pictures, right? But if you've been watching our updates long enough, you may remember the period of time when we had these crater walls that were colored white or yellowish, that had all these gas deposits on them. All those crater walls are buried. You see a little bit sticking out over here, maybe on this side. But all that stuff is buried now. And so all that gas that was coming out below on the crater walls is now coming out beneath this crust as well, and it's coming out in similar areas. And so we have now a more diffuse pattern, and I imagine I can only speculate, but I would imagine and not be surprised if it's a larger challenge now to measure this gas because it's coming out of lots of different places, more diffuse across this more than 200-acre area, rather than one single hole in the ground, right? Even 2008 to 18, it wasn't a smaller area than we have this large crater floor has vents all over the place. So that's something to note there, all these different spots and the possible challenge of that. And I say that because if we look at our last month of SO2 plot from USGS here, once again, tons per day is on the left. This is the last month on the right here. So we've had, at the top here, I'm also showing the last month of Summit Tilt at the summit, Uikahuno, right? So for the most part, it's been high. And then we had a Deflation Inflation event about 2 weeks ago, and it's been mostly high, and we had this Deflation Inflation event that just ended right around now. And you can see for the most part, the gas levels have reflected that, being high, fairly consistent, and then dropping down during the Deflation Inflation events, then back high, similar for here. But what we've had here in the last couple of weeks, and maybe I'll zoom it in once again, maybe not quite yet, but maybe I'll show at the top here, the tilt has been relatively flat, apart from the Deflation Inflation event. But our gas is showing maybe a little bit of a trend, and maybe we don't have enough data to really believe it too much, but this is probably the Deflation Inflation event. No surprise to see it low there. But this slightly decreasing trend there might lead you to wonder, well, are we losing some of the measurement somewhere else? Is the gas really going down? Is it going down because there's less lava actually coming out, or could there be some larger error involved there, right? So that's what I'm wondering here, and that's part of why I brought up that image in the last slide there, showing you guys the diffuse gas coming out all over the place there. All right, so let's see where we go from. Right, that's the gas story. So let's review here the last couple of weeks, or the last week first, and we'll go further back from there. But looking at the KW camera, this is an animation that Dane made using just the nighttime slides from the KW camera. So it does have a few gaps here, but it really does show the pattern more clearly without the strobe effect there. Right, and so since we're going across the whole week, and the week ends with the last couple of days being essentially a lull, you're seeing the cycle of perimeter ooze-up flows. You can see there's a center here, there's one there, 2, 3, 4, 5, 6, 7, you count the west vent area over here, maybe 8, right? Lots of different areas all around the perimeter coming up. That's in addition to these west vent flows that have been building up, continuing the activity from last week, and this persistent lava lake that we already looked at a little bit here. There's that pattern with that high, lots of ooze-up flows, west vent at the same time, and then comes the lull. Everything essentially dies off, lava level drops down, but it still keeps going. And then at the very, very end there, it actually bursts forth again as we come out of our deflation inflation event. So our F1 camera, thermal camera, is that same view in infrared here. Or thermal, I should say, right? And you can see that same view. There's our west vent complex building in that zone. You can see some of the ooze-up flows here, over here, across that back wall, way over there. This very southern west vent complex zone maybe has it's hard to tell here exactly where the lava outlet is. It looks like it's right in here, maybe very edge. So kind of part of that crack, and you can kind of see the darker color blue here is that cooler zone where the lava hasn't flowed as recently as that core zone right in there. So this is that last week. So one little follow-up from last week I wanted to mention here. We couldn't quite find this on a flight at the end of the last eruption, right? But this is from professional paper 1867A, between the 2008 to 18 lava lake. And here's an example when lava was in that pit, when they were noting puffing vent on the floor collapse, lava lake appears, and then corresponding tilt signal here as well. Right? And this looks like it's about maybe 2 weeks, we'll call it, more or less, right? So what you see is deflation inflation event with an offset from floor collapse. Deflation inflation event right there. And then you have right here this zone where this is what I wanted to point out, especially this pattern of gas pistoning, right? So these seem to occur together, the gas pistoning signals. Here's a couple of them right there. They can occur together, interspersed with deflation inflation events, interspersed with other offsets, whether they be crater collapses that are local, when they actually have offsets. Sometimes recently we've seen more of these spikes from earthquakes we've had around here, jolting the instruments. But in any case, that's just some of the background rationale for that. If you haven't been with us for long enough to see these gas pistoning videos, I'll play it one more time here since it's always cool. This is back from the Pu'u'o days within Pu'u'o crater. The idea is that bubble of gas is coming up and lifting a slug of magma ahead of it, and then as soon as it can reach the surface and pop, that slug falls back into the hole or spatters out a little bit. But essentially it's just like a puffing venting of the gases of the volcano. That's that gas pistoning effect. This is on a very, very smaller surface level. Gives you an idea of what we're talking about when we say gas pistoning, right? So processes like that, the gas moving in slugs through the conduit, whether they're actually causing what you're visibly seeing here or not, that kind of process is what I imagine is what we're seeing when we come to here to our right. So if we look at the last month plot, here's a big deflation inflation event. And then here are those little spikes that look like gas pistoning. And you see a lot of these little variations. It could easily be that kind of thing. Here's one of our close by earthquakes, putting a spike in our graph. Another earthquake down here, putting a spike in our graph. And a big deflation inflation event. Lots of other little variations that are hard to really quantify and call meaningful, given the scale of what else we're seeing happening here. Other variations. Okay, so that's the 1 month tilt, and we talked about how there is maybe a little bit of a disconnect here with this gas trend, a little bit maybe. And if we put our 1 month lava depth plot alongside our 1 month tilt plot right here, you can see that really over the last couple of weeks, it's coming up at a much slower rate, right? A very much closer to flat line, whereas it was much closer to like that angle, maybe through about a week, 2 weeks ago, and since then it's been coming out a little more gently. So a couple of possibilities there, right? One is that we documented from the USGS maps that it seemed like the eruption rate had gone up a little bit and then has come back down again. So we're back to our normal background long term that we sustained for decades with a pool eruption. So there's no indication of anything amiss there. That could be a natural slowdown if you actually go back to normal, right? But if we let me go all the way up here to the summit plot all the way from September till now. And so we were just looking at the last month is just right in here. And you can kind of see that, well, maybe you can't anymore. And there's our initial filling of the crater floor. We have some offsets to the lasers pointing to different pieces of island and parts of the lava, parts of the shelf. Eventually it's pointing to the active lava lake, and it sees the rising and falling up and down here. But still the trend is pretty much following, you know, the top of those peaks there, for example. Then we have a little bit of data gap, and then we do seem to see a little speed up right here, right? So I do believe that could be that little bit of a surge we saw. And then since then we might have a slower rate. But really at the very end here, it seems like it almost gets flat. Right? So the little flat part's what I'm wondering about more so. And now I'll come back down to where we were, right in here. This little flat part at the end. Right? We don't really see any change in the tilt as well. So you got to wonder, is that really the gas, or is it a similar issue, right? So one possibility in lava is slowing down coming out, and there's less gas and there's less depth for the same reason. But on the other hand, you wouldn't have continued to see all those ooze-up flows during that same interval, right? So really, we got to remember that this laser is pointing at one point of the lava lake that's kind of close to the middle, and now it's like the edge of the lava lake. And if lava is coming up and bulging that zone and then spreading outwards and filling the perimeter of the whole crater, that maybe it's not bulging up as fast, and maybe it's oozing out to the sides, and you're not getting as much upwards motion in the middle, since it's sprawling out to all those edges as we're seeing, at least prior to the deflation inflation event. So that's another possibility there. Zooming a little bit closer here. Here's the last week summit tilt. See down and up, those couple earthquakes. We'll discuss earthquakes in a bit here. And our 1 week depth. You can see it's been rising slowly with these little variations, right? Remember, we're looking at some part of the bank here, but our scale really isn't that big, right? We have 31.5 at the bottom and 342.3, so we really have, what is that, 1.8 meters scale across the very top to the bottom of the thing. So really in the last week, we've come up net of 0.3 meters or so. Really not as much as some of the previous weeks, right? At least where this laser is pointed. So that's where some nuances with the monitoring signals here. We'll have to maybe wait for USGS to chime in exactly, but those are some possibilities of what might be going on and why those time lapses are so valuable. Really help tell the story of what's going on here. All right, so I mentioned the deflation inflation events. I thought I would zoom in just on the last filling, dropping and filling of the deflation inflation event, just so you could see, apart from everything else, when the inflation comes back, we have a little spurt comes out of the west vent complex right here. You see the lava levels go down and up, but continue circulating. It might be hard to see unless we really just trim it like this, right, and isolate it. See that west on vent also active and still. So that's the last couple days. And here are the last 24 hours showing on the USGS webcam right now. You can see a little bit more clearly the spillover from the West Pond area and from the spin complex. So, guys, it's coming out tonight or tomorrow morning. Very possible to see activity still from these areas. Okay, so now the last month. And looking back over the last month, we can more clearly see this pattern we've just discussed, having seen all those plots, right, with more ooze-ups and then the pauses. So over the last month, we've actually had two lulls, the one 2 weeks ago and the one just ending now. So you can see two slowdowns, right? There's the first one right there. And lava comes back, the west vent complex starts becoming more active than before, and here's a second one here. Compared to that earlier late part of March, about a month ago, lots of flows were active on that eastern part of the crater floor. We're not seeing nearly as much of that now. It's more along the perimeters. So that's last month. One other point of emphasis here is just looking at the whole last 3 months, and what I've done here is just rocket forward and back and sped it up extremely. So you can see this long-term pattern, in, as I described, this inner crater floor crust rising up and stuff oozing up from the edges. You can maybe see it here in motion over the last 3 months, right? There's that core area centered right in here that's darker blue that occasionally gets flooded with lava, but for the most part has this intact core, right? And then inset in that core is this active lava-like area. It's persistent. So it's acting independently as that whole floor is rising. That crater floor area is still shrinking. It's now probably less than 2% of that entire crater floor in that area, 2%ish. And much of the flow is coming out through these big ooze-ups elsewhere. Big ooze-up flows elsewhere, and it's this one vent area is becoming less important because essentially you're having lots and lots of vents all around the edges with these ooze-ups, given the volume of flow coming out. And this has become somewhat more of maybe the dominant gas vent, but still not the full gas vent there. It's longer term. Okay, so I came across, and I thought I'd pull this up and share with you guys. This is one of the old animations published by the USGS of the opening sequence of this eruption. Zooming in here back from September 29th to September 30th. When the fissures opened up across that old hardened crater floor and started spreading out across the perimeter. It's all daytime, so it's all light gray here. But really wanted to point out there is those grayish, whitish and yellowish gray crater walls, right, where the gas vents coming out of them there that we saw for a long time. So just for point of comparison, in the animation, a more recent photograph. This one, I want to say, goes back to maybe about a month ago, still in March, the last time we had a similar kind of angle. But you can see none of those yellow crater walls anymore. See, flooded that lower down drop block area here, and starting to do it over here. And while we'll be talking about it coming up onto this cliff area zone, the next area that it gets to after it continues flooding all through here, up through there, together. So for now, most of the encroachment is happening over here, and it will be that will be the case. Our projections are probably through most of the rest of the year. It's going to be rising up here, and if it keeps going at a similar rate, then maybe by the end of the year you might see it coming up onto this level of where it can start spilling onto here or spilling onto here. So we saw some of the questions come up after our last live. People plan on coming and visiting later in the year, and it all depends on the eruption rate. And if it stays the same long term, which it has done in the past, then you're plenty to see, getting better and better and better. But that's the one X factor we can't really predict. We're essentially just looking at what happens, reacting to the monitoring signals. All right, let's finish up with the earthquakes. Here is earthquakes over the last year in the Kilauea area. And you can see still pretty low. Maybe a slight little bump here, but this is because this 1 year earthquakes does catch the Pahala area as well. And we'll have to discuss that as we look at the 1 month earthquakes here. We had a big jump both in a moment in the red line and in the counts here, where we actually had over 120 earthquakes in a 1 day last week. So coming back to the 1 week plot here, this is the whole area that's being captured, and you can see on Kilauea, pretty quiet actually, very little at the summit. South flank is still going a little bit, really not that much either. Most of the action's over here in Pahala zone. So we'll transition to talking about that a little bit here. You can see several big deep earthquakes and a few shallow ones as well, right? But nothing connecting the two. There's no upward progression of earthquakes that would indicate magma movement. It's probably just magma building at depth still in this area that we think is a feeder zone, both to Kilauea and to Maunaloa and to Loihi. And then as the ground above it bulges you have as in earthquakes in that shallower part of the crust where the crust is cool enough to actually crack and break and not just kind of deform and adjust in other ways. Right, okay. So here, so yeah, maybe I should have mentioned this is depth and then this is longitude here. So this is essentially cut through this upper map right here, right, cross section. And now we'll switch to, this is depth and this is time, the last week here, right? So that was that big earthquake that occurred and there were lots of aftershocks that occurred essentially there, right? Occurring at that lower level, all through there. Then you can see that larger, shallower earthquake comes in later in a sequence here, more recently in the last few days. And it has its own aftershocks and associated events too, right through there. Looking at the last month, you can see more of the long-term pattern of Kilauea, the south flank, some deeper earthquakes here. Some of the earthquakes under the summit are more evident. Pahala is obviously still there. There's a cross-section of the last month under Kilauea summit zone. Pathway coming up that way, right? So you imagine there's some pathway that connects from there to here and up, possibly, at least, right? It could also be coming up that way too, who knows? And really, you can see that there's been fairly constant activity. Even that big earthquake is just one in a large, long sequence for the last month. It's not like it came out of nowhere. That's been active for a long time in the zone. And it's a topic we keep punting on because it's hasn't changed in years and years and years, and we'll repeat ourselves on that sometime soon, I suppose. Back around. Okay, so that's the earthquakes and the USGS plots. We come to the map that perhaps most people are used to seeing. And there is our big island of Hawaii. There's actually one earthquake off Maui that occurred, 2.4, 35 kilometers down, very deep. Flexural adjustment of the crust from the just settling of the islands happens over in Maui too. Pretty small one, but coming down 3.1, 31 kilometers down, pretty deep on Kohala, similar. 2.1 offshore, 7 kilometers down, and that's, I call it similar too, right? And that lets us focus in a little more here on what's happening in Maunaloa and Kilauea. What I've done here is I've ordered our last week of earthquakes by largest magnitude. So we actually had a 4.6 and 4.3 that came seconds apart, 8 seconds apart, 9 seconds apart. First the 4.3, then a 4.6. This happened at about 2 o'clock in the morning. It awoke many people that I've talked to. It woke me. I think maybe the 4.3 maybe woke me up so I could feel a 4.6 a little more easily. So interesting, but it wasn't anything that was alarming at any point. It was just our regular deep Pahala earthquakes, kind of a rocker. That's probably how I describe it. So those two, and we have a USGS statement we'll mention here in a second. But besides that, we have a 3.5, almost 1 kilometer above sea level, right at the surface, up near the summit of Maunaloa. So that's notable. We'll have to look at that one as in Maunaloa here shortly. But then we also have the 3.4 is that shallower event that occurred yesterday at 7 kilometers depth, Pahala zone, above that area we discussed. 3.3 down in that area as well, 3.1, 3.0, and then we're down to 2s after that, right? And there's lots and lots and lots of those. All right, so that covers our bases as far as what's out there, and we'll try to wrap it up here pretty quick. Because we do realize there is a Merry Monarch Festival, Aloha Hula, coming up. For some of you guys interested in watching that. So USGS info statement, Friday, April 15th, 2 a.m., 4.3 and 4.6 minutes apart. And you can see the statement here, strong shaking, maximum intensity of 6 on the modified Mercalli intensity scale. Over 400 felt reports within the first hours of the earthquake. So, according to HV geophysicist Jefferson Chang, these earthquakes had no apparent effect on Kilauea or Maunaloa volcanoes. It appears to be part of the seismic swarm under Pahala, which has been ongoing since 2019. They've been observed as far back as at least the 60s, and there have been no detectable changes anywhere. So, really, nothing alarming there. But let's keep going any earthquakes to Maunaloa. Let's look at Maunaloa, the big picture first. Earthquake rates over the last year. You can see there's been no change really in earthquake rates of Maunaloa. We did have that event that if you look at the red line shows that we've had a couple of these 3-pointers near the summit that have added some cumulative moment to the graph here. There haven't been really big leaps in a number of events, but we had like one here, and so they're happening a little bit more frequently than before. That's interesting. It's certainly notable. The last week, see, there's that event plotted in red in the surface. Bigger for you guys. Right there, as part of you can see a more dispersed upper southeast flank. That's area northwest. This is all normal stuff. It's really not that many. Essentially, it's just where they are, which is interesting here, right? Really, we got to go to the month plot on Maunaloa to get enough data to really see the patterns a little more easily. And now it starts looking more interesting, right? You can see the lineation of these shallow earthquakes starting to occur under the caldera and upper southwest rift. Continue to see this northwest of the caldera cluster, and you continue to see these upper southeast flank cluster. One deep one, the blue one right there. Let's look at it in cross section. So you can see here this line. I kind of wish it wasn't so squished, right? But you imagine magma chamber is kind of in there-ish. And so it's pushing up. It's pushing outwards, and so that's why you see these earthquake zones there and there, and it's pushing the southeast flank, which is able to move. So the whole thing moves, and so you see this whole area expressing earthquakes right there. And then a deep one, possibly near the conduit, or hard to tell what's going on there, but you gotta wonder, being so close to the summit area, possibly related to the conduit, to that deep zone coming in. And Pahala in this case is not on this map. It would be off to the south, and so it would feed into here, then come up possibly. So the volcano is alive. There's magma building up in there. Apparently, it seems to be adjusting with these 3-point earthquakes. It seems like the flank is still mobile. It's building enough pressure, even with the flank moving, to activate these earthquake areas in the northwest and on the summit a little more than it has during the fairly recent quiet. So nothing to be alarmed about yet. We've seen much higher levels than this without anything actually happening afterwards, but it's just a slight change to report and to note for the close watchers here. Nothing to be alarmed about, and know that we are watching it here. There it is the last month. There's that more recent 3-pointer. One before that. See the levels are still pretty steady. And tilt, no real change over the last month. It's important to note on Maunaloa that the tilt and the GPS stations really are fairly tight in on the caldera, right? Whereas a volcano can deform over larger areas. We've seen from InSAR images in the past, right? So sometimes that this factor doesn't catch the full, like this area doesn't move as much, but you can have more sprawling, especially in this direction over here, right? And bulging possibly, or who knows what else happening over here on this other side. So that said, within that summit area, no changes in the tilt. Look at the cross caldera distance over the last year. I have quite a bit of scatter here, but really no notable change there either. Nothing convincing, whether it's up or down or flat. But that's all we can say, is that in that small area, we do know that earthquakes are happening a little bit more as far as one large event, and that's a pattern we saw when we saw southeast flank movement in the past. So essentially, magma's coming in, it's able to move and adjust, and everything is still good. No cause for alarm on Maunaloa. And likewise, the USGS alert update on Maunaloa last week. Put it here. Oh, no. So leave it. So in any case, it doesn't say anything different. No real changes. 77 this past week. All right. So we'll wrap it up here with this week's Volcano Watch. It's Earth Day, my Earthlings article today, and this is connecting volcanoes to changes in an environment, right? At 3 different scales. First, a local scale. They have an image here of Haleakala, Maui Silver Sword. I'm in a crater of Haleakala that growing approximately 410 to 530 years post-eruption. They have fireweed growing here in the slopes of Mount St. Helen, 5 years post-eruption. And they have down here Kilauea Iki crater floor, 56 years post-eruption, an ohia tree in bloom down here. This is photo by Nate Yuen, photo by Lynn Topinka, and photo by Paul. I'm sorry, Paul, I'm going to blow up your name here because I don't know if I can read it. Krishelnicki, maybe that's my best guess there. All right. So, not to go through everything, but in honor of the Earthling article here, interesting to note that on a local scale, you can have some very dramatic changes in environments, and of course, over time they revegetate and regrow. So it's like a dynamic back and forth of life in volcanic terrain that occurs on a local scale. But looking at a larger picture at the whole Earth and considering not just environmental change but climate change, there's a couple of other different ways that they discuss here. Maybe I can pull this up. One is the actual ash that's put into the air, which can essentially change weather patterns, right? Reflecting radiation back into space. So in that case, it can have effects in local areas like Krakatoa, Indonesia. Throw darkness for 2.5 days in that region, and temperatures were lowered globally for 5 years. There was a year without a summer from Tambora in 1815 across Europe and North America. So those are examples of kind of ash going into the atmosphere and causing fairly short-term, could be a few years, right? Short-term geologically, right? Could be devastating for people, populations, of course, right? But as far as geologic record here, fairly short-term events from the ash going into the atmosphere, right? So we have that more global effect of ash in the atmosphere. We have the local effect of lava flow to rainforests in as little as 150 years with the rainfall of East Hawaii, for example. But one topic that often comes up is the gas put out by the volcanoes compared to greenhouse gases put out by people. So that third and last point, considering the greenhouse gases in particular, CO2, carbon dioxide, it's worth noting we normally talk about sulfur dioxide on here because that's the one that's more often measured, related to the near surface effusion of lava, the one that we can smell and is more easily detectable. So that's what we usually talk about. CO2 is also important. It's also a large component of the gas that's put out, major component. And so when we talk about greenhouse gases, we're talking more about the CO2 here than we are the SO2, at least as far as these articles are taking. So as far as CO2, to get anywhere near the human scale of emissions, it has happened in the geologic past, but you got to go back to before there was really very, very much complex life, right? 250 million years to the Siberian traps, flood basalts, where there were mass extinctions, and something like 3/4 of all species on Earth died, more or less. It's been a long time since that kind of thing happened. It can happen. That'd be pretty rare. They're talking about when that kind of thing happens, like the ocean at the equator is like 40 degrees Celsius, 104 Fahrenheit. Like everything's dying. It would be really dramatic, right? Hopefully, we won't ever see that kind of thing. In comparison, the normal amounts of lava today produce more than 100 times the greenhouse emissions, right? One of the numbers I saw was about 135 times, actually, right? So one way that they're putting this is Mount St. Helens would have to erupt over 3,500 times a year to match human CO2 emissions. So do volcanoes influence our local environment and global climate? Absolutely. But we shouldn't blame them for or rely on them to solve our current climate woes. So they do exist, but really it's not really not really an out, right, for any of those discussions. And to just put it a little bit further here, right, here's a plot going back from 1900 to 2010, I want to say. And this is just a ratio, right, to the 0.26 gigaton per year global CO2 emission rate estimates. That's the long-term estimate here. So you can see that even back over 100 years ago, we were in a range of 10 to 20 times the amount of emissions put out by volcanoes is what people were putting out. And really, we've grown quite a bit. Now we're up at that 135 zone right there. So yeah, volcanoes are important. But when it comes to CO2 especially, right, there's really no comparison there. Even if you take this low end of the plot right here. That's the contribution from Volcano Watch this week, and we thought I'd throw a little bit extra in there, and yeah, we'll wrap it up here because we know Miss Ahula is coming up. So Dane, we'll take a couple questions, and we'll try to wrap it up here in the next 5 minutes.
All right, I want to give some shout outs real quick. Got to acknowledge some people. First is we had some super chats come through. First was $50 from Tim. No comment on that one. Appreciate you, Tim. We had Gary Bryan come through with his $35 super chat. Says, thanks, Phil and Dane, for these updates. Thank you for the continued support, Gary. Then we had a $1 donation from Sean. No comment on that one. I do want to also encourage everybody to like, subscribe, share, all that jazz. Also, commenting after the video is over really does help with the algorithm, that kind of stuff. We do post all this stuff to hawaiitracker.com. So if you're not a member there, go check us out. We like to thank our sponsor also as well, Kaleo's Bar and Grill in the heart of Pahoa, for their continued support. They have 2 different locations, one in Pahoa, one in Orchid Land, and that new Orchid Land location is really nice. Definitely check them out, and we appreciate them with their support. We do have a couple questions we can just glance off of maybe.
Yeah.
All right, so Richard asks, the next time the crater collapses, will it collapse into the current vent or into the previous pit where the water lake was?
That's a good question. I think it really depends. A collapse has to occur because something left that area, so it's more about where the lava can leave from to go somewhere else, right? So
right,
you'd imagine right now the deepest point of that crater is where the water lake actually was. So I would expect it to sag more there as well. But
the thing that immediately jumps to sorry, go ahead.
Yeah, you could have, it could not be the same original V shape. You could have like that where the vent's been active in that west area could have been eroded by now. So it's also like a secondary zone of collapse. You could have both of them actually, in fact, happen.
Yeah, the way I see it is, in the previous collapse, everything around the conduit was hardened lava. It's been hardened for years. This one, we still have that whole dimensions of that collapse area and that volume of lava inside the lake. I think all that, or the majority of it, would drain back if it were to drain. So you'd get a big old hole again. Not as quite as big as it was before, but going for that type of thing. At least at the surface level.
Yeah, I mean, you could have
thinking about it out
lots
loud.
of little holes all around the outside. We're starting to see
right.
a little bit of that right now. Lots of at least a few little holes. So it could go that way. Yeah.
All right.
Interesting discussion. We'll have to wait and see.
And then going along with that, we have another question about how big if it were to drain, how big of a gap would it drain back through, do you think? Would it be similar to the old conduit dimensions, or would it be smaller? Or would we even have a clue until it did it?
I think that's a great question. I mean, yeah, it's hard to know that also, like how far down, how big is that gap? Yeah, it's one thing that's interesting to me that I'll mention is that we haven't discussed it at too much length, but there is a period of time between the last eruption that ended in May of last year, until September of last year, where there was no lava coming out, where we did see settling of the crust occurring. It occurred around where the active lava lake area was, and so like if you look at the ending elevation of the lava lake in March or in May, it's not the same as a starting elevation of lava lake for 2021. It actually sagged down in between. There was a loss, and I want to say it was in the order of 10 meters, 20 meters, something like that. 30 to 60 feet, something like that. or like maybe you had a largest pocket of gas or what a frothiness or settling could occur. That was the scale of it. So I'm tempted to say something like that. When we look at the actual persistent lava lake now and see the lava levels rising and falling, they're rising and falling about that as well. Ballpark order of magnitude, tens of feet, tens of meters, something like that.
Right.
Best guess.
All right. Well, we got time for one more question here, and Michael T just made a $2 donation, and I had his question queued up right here. He's asking, is Diamond Head due for an eruption anytime soon?
Well,
we've answered this question in various ways about like Mauna Kea and stuff like that before. So
yeah, the short answer is no. There's been no indication of any activity there. Now that said, there have been lots of eruptions being documented, and you really got to go to University of Hawaii Manoa to find expertise on this, right? But they've documented lots of eruptions offshore, all around Oahu, around some of the other islands, and we're not quite sure how that would go and what the buildup would be and what we would see how far in advance. In any case, we're not saying anything, so the short answer is no.
All right. Well, that does it. We get in at 1 hour today. We will be back next week at our regular time of 5 p.m. Hawaii Standard Time, unless something happens, and then we will go live and bring that to you. But not really expected right now. It's pretty stable.
Yeah, go check it out.
Yeah, with that, I'll pass it to you. If you're if you come some great lava viewing up there, so I'll pass it to you, Phil.
Yeah, I'm sure. Yeah, we're gonna try to cut it off here real quick because Merry Monarch, and yeah, if you're in town for Merry Monarch or curious about Merry Monarch, a lot of the hula is about the volcano, so there's a definite connection there, and go check it out and see it. Yeah, so mahalo everyone for your support. Like, share, subscribe, comment. We'll catch you guys next week, same time, same place. For HawaiiTracker.com, he's Dan DuPont. I'm Philip Ong. Aloha, everyone.